Now what we're doing in lesson 3 is actually applying the formulas for magnetic fields. We're still going to be determining directions, but now we're also going to be looking at doing some calculations. The formulas are actually quite simple. The only thing that you're going to have to do is kind of look at the question and say, is this a current carrying conductor, meaning a wire carrying current in the magnetic field? And then you'll use the appropriate formula for magnetic force with a conductor. Or is this an individually charged particle? And you'll use the magnetic force formula for that. And we're going to look at a couple examples in each. Our first one, a wire of length 48 centimeters, so I'm just going to highlight some of the key words in here, carries a current of 780 milliamps horizontally eastward, and here's the magnetic field. Determine the magnitude and direction of the force on the wire. So since we're talking about a magnetic force, we can use this formula. Magnetic force equals I L B, and I'm not going to use the absolute value symbols that you see on your formula sheet. All it's really telling us is that we always put in the positive value of the magnetic field, and we always look for the positive version of the force. It really is just stating to you that you determine the direction regardless of the numbers. The direction does not come from the numbers. The direction comes from which direction is each one of these vectors pointing in. The other key thing is we have to make sure we're in right units. When we're putting in the current, it has to be in amps. So 780 milliamps is 0.780 amps. We have to put the length in meters. So 48 centimeters is 0.480 meters. And the magnetic field has to be in Tesla, which it is 2.75 times 10 to the negative 4 Tesla. So if we punch these numbers in, 0.78 times 0.48 times 2.75 to the exponent negative 4, we should get a magnetic force in, or magnitude anyway, of 1.3 sig digs 03 times 10 to the negative 4, and units of force are newtons. So I always go and just determine the magnitude first, then I go back and I start thinking about the directions. So I have the current going to the east. That means my thumb will point to the east on my page. The magnetic field vertically upwards means coming out of the page. Right? The plane of your paper is north, east, south, west. Vertically upwards is another way of saying coming out of the page. So if you look at this little picture here, I'm trying to represent here for you the magnetic field coming out of the page, the current going to the east. That should tell us our force is to the north. Top of your page is another way to think about it. So your plane of your paper was north, east, south, west. Thumb to the east. Upward means coming out of the page. So your fingers are pointing upwards on your left hand.